Hi, my name is Joshua Fan, and I am a PhD student at Cornell in computer science. And I broadly study how to design AI methods that can be applied to problems in agriculture and sustainability, and particularly how to make AI methods require less data. So one of the projects I'm working on is that I'm collaborating with soil scientists to help simulate the soil carbon cycle better. So, soil organic carbon is really essential for soil health and is really important for improving crop yields and improving resiliency to drought. And it even has the potential to remove CO2 from the atmosphere and mitigate climate change. However, we really don't have a good understanding of even basic things like how much carbon is being stored in the soil right now and how long can it stay there. So scientists have created really complex mathematical models that simulate how carbon flows through the soil. But they do have a lot of unknowns. There are many complicated processes in the soil that we just don't have enough data for. What I worked on together with some wonderful colleagues in soil science was just designing a way to embed these mathematical models into an AI model so the AI can basically fill these unknown gaps and predict some of these processes that we don't really understand that well. In this way, AI can respect existing scientific knowledge while also filling in some of the gaps in our knowledge using observational data. And on top of that, we also modified traditional AI methods to make it more interpretable. Instead of just being a black box that just spits out a prediction, our system tries to be more transparent and allows scientists to understand how various environmental factors like temperature can directly affect these hidden processes in the soil. So, what inspired you to work at the intersection of AI and environmental science? I come from a computer science background. At first, I just really enjoyed learning about the latest AI techniques and just understanding the technology behind them. But at the same time, I also wanted my work to be really impactful for society's biggest problems. And I think a lot of society's biggest challenges are actually in agriculture and environmental science because we need to really figure out how to feed a growing world population in the face of a very unstable climate. I thought that this is just a wonderful area where it just both connects to the world's most difficult problems and also has opportunities to kind of innovate in the AI space. Standard AI methods often don't work well for agricultural or environmental problems because there's just not enough data in these fields or the data has a lot of biases. It just looks different from the typical applications that people develop AI for. And I thought this could be a way to both make an impact and also deliver cool technological innovations. What developments in AI are you most excited about for the future of agriculture and forestry? So there are a lot of cool techniques in AI that are being developed, so it's very difficult to choose. And I think there could be a lot of impact from just combining a lot of different techniques that have just been starting to mature. So, of course, one of the ones that I work on is knowledge-guided machine learning, which is basically how to combine existing scientific knowledge with learning from data. So a lot of traditional AI methods are just purely based on learning from data only. But we also have a lot of scientific knowledge about the world, such as like about climate or agriculture. We have a lot of knowledge about how plants grow or how the weather works in terms of, say, equations or other forms of knowledge. We now have some tools to actually combine these like really advanced scientific knowledge that has been worked out through centuries with the power of data. But on top of that, we are now starting to develop ways to combine multiple forms of data. So previously, traditional AI models mostly focused on one type of data, like text or images. But now we are starting to scratch the surface of how do we actually combine them. And that's really important in, say, agriculture, where we not only have weather data, but also all types of images, drone images, satellite images, soil data, and even textual data from people's notes. Just figuring out how to combine all these data together into a much more comprehensive model uh, could be very impactful. And now that, of course, language models are starting to become more popular, this does have the potential to allow farmers or other practitioners to directly talk with AI interactively, and then the models can start to go beyond just making predictions to help actually guide decision making and planning. What's the most surprising insight you've gained from working with ai-leaf? One of the most surprising insights was both how challenging and rewarding it is to work across disciplines. I know in computer science, this is still relatively unusual. We often tend to work on very well-defined problems, such as how to develop a better language model or how to recognize cats and dogs in images. So actually working in a more complicated application like environmental science was actually quite challenging because I not only have to be an expert in AI and computer science, but also have to be able to communicate across fields and be able to sort of understand perspectives from other domains such as soil science and agricultural economics. So it does require quite a lot of work. And honestly, it's not the most straightforward path because it hasn't been well trodden before. But on the other hand, it's also very rewarding because the insights from soil scientists, for example, really helped me build much more scientifically informed models that I, as a computer scientist, would have never been able to develop alone. So I think it does take a lot of work in order to collaborate with people from very different backgrounds, but oftentimes the effort to communicate and work together is very worth it. Thank you. Thank you for listening.